Hello everyone, you're welcome again to Tutor Stanley Learning Space. So today we'll be looking at aromaticity, checking for aromaticity. The question says, which of the following is aromatic? We all have what? A cyclo compounds, a cyclo molecules on the board. Which of them is aromatic? Are you there? Now, these three elements, these three figures are the same, but this and this are the ions. Now this is cyclopentadiene, cyclopentadiene. Abi? Now this one is what? Cyclopentadiene anion. This one is cyclopentadiene cation. As you can see, anion, cation. Is that clear? So, how do we find out if these are aromatic? Number one, since this is, we have first rule is what? Check if they are what? Cyclic. That is rule number one. Check if they are cyclic. Rule number two, check if they are planar. Rule number three, check if they are delocalized. Check if they are delocalized, which involve what? Having a having conjugation. Then this one, the Hooker rule, Hooker magic number 4n+2. The Hooker magic number. Is that clear? Now let us start from the middle one, which is the normal, the cyclopentadiene itself, before the ions came. Before the ions come, rather. Now, first one, cyclic. This is cyclic because it have a closed ring system. So we mark cyclic for it. Cyclopentadiene is cyclic. That is not enough to say it is aromatic. The next one, is it planar? How do we know if it is planar? For a ring system to be planar, all the connecting carbons must be sp2 hybridized. There should not be a bridging sp3. Once there is any sp3 carbon, that is single bond throughout, that comes in between, it have destroyed the aromaticity. So here we have, this is double bond, then this one is not a double bond. This is sigma bond throughout, 4 sigma bonds. So this carbon here is sp3 hybridized because of what? It is all 4 single bonds, right? So because of there is an sp3, here is sp2. So because of there is a connecting sp3, so this molecule is not what? It's not planar. And because of that also, it is not what? Delocalized, because it is not there. This have destroyed the conjugation. Conjugation is what? Every carbon in that ring system having contact with a pi bond. Now this is where the thing starts. Now these two carbons here, there is double bond here. The next carbon here, another double bond begins here, stopping here. So this 1, 2, 3, 4, they are all, if not that this one is sp3, this one would have involved conjugation. So but sp3 have destroyed it. So therefore it is not what? It is not delocalized. Finally, we check for the Hooker number. The double bond, we can only see 2 double bonds here. And the double bond means what? 2 electrons. Chemistry student, can you remember? So since we have 2 double bonds here, this means what? 4 pi electrons. And the Hooker number says what? This Hooker number, you don't see it inside this molecule. It is just like some people call it magic number. It's just a magic number that we use to get succession of number of pi electrons you will see for you to say that a compound is what? Aromatic. It's just like, a good analogy is the AP, arithmetic progression in mathematics, where you have your difference. D is equals to 1, D is equals to 2. Exactly. In these successions, the difference is what? 4. So that's why the number, this magic number 4n+2, even if we make any 0, 4 times 0 will be 0 plus 2, that is 2, right? If you make n1, 4 times 1, 4 plus 1 plus 2, 6. If you make n2, it becomes what? 10. Successively like that, 4 by 4 by 4. So how many pi electrons do we have here? We have what? 4 pi electrons. So it does not satisfy Hooke's number. So cyclopentadiene is not what? Aromatic. Now let us look at the cation. Cyclopentadiene cation. Now, because this cation means what? There is a removal of what? Hydrogen anion. There is a removal of what? Hydrogen anion. This is normal hydrogen with what? We know hydrogen to have what? We know hydrogen to have 1 electron. So hydrogen anion now means what? Minus always means that what? You gain an electron. So hydrogen ion means what? 2 electrons. Hydrogen with 2 electrons. That is, the hydrogen took one of the electrons from the p orbital of this carbon. Normally this here is supposed to be sp3, but hydrogen, the removed hydrogen have taken 1 electron from the what? From the p orbital. So instead of having p3, we now have p2. So there is an empty p orbital here. So that is why we call it carbocation. So since there is an empty p orbital, this carbon now becomes what? sp2 hybridized. It is clear, right? No longer sp3, because one of the electrons have been lost to this one. The participating hydrogen in the normal sp3 bonding, right? So this carbon becomes what? sp2 hybridized. And because it is now sp2 hybridized, it is now acting as a conjugate, supporting or contributing to the conjugation of this ring system. So, and the electron also becomes what? Delocalized. So this becomes, it is cyclic, it is delocalized, it is planar. Because of what? This sp2 is now having the same shape with the sp2 of these ones. So finally, the last one is what? We also use what? The Hooke's number to determine finally. Because those other 3 is not enough to determine. You must satisfy Hooke's number. You can see some cyclic molecules that are conjugated, but they are not aromatic. So finally, let us check. So we also have 2 pi bonds, that is 4 pi electrons. This sp2 does not have any pi bond in it, so it does not add any pi electrons to this. So therefore, we also have what? 4 pi electrons. So cyclopentadiene cation is not what? Is not aromatic. Now we are left with what? Cyclopentadiene anion. Is this one aromatic too? So it is almost the same as what? The cation. It is cyclic because of the closed ring. Then it is planar. It is planar because of what? This carbon also, the minus. For it to be minus, there is a removal of what? Hydrogen cation. Hydrogen cation means what? Even the 1 electron in hydrogen was taken from hydrogen before it was removed, and it was added to what? To the p orbital of this sp3, supposedly sp3 hybridized carbon. So because of that electron makes it what? There is now a lone pair. There is now a lone pair in the p orbital of this carbon. Therefore, this carbon is not also sp3 hybridized. It's also because what? sp2, right? And because it is sp2, just like these ones, so it is planar and it is what? Delocalized. Because there is already a double bond, it is delocalized because, and it involves what? Conjugation. There is conjugation. And finally, how do we know? Does it satisfy the Hooke's law? Now, there is now 1, 2, and now this is serving as a double bond. Because of what? This lone pair also count as what? As a double. So it is contributing to the pi system of this ring. So there is 1, 2, 3 pi bonds in this system, which means what? And a pi bond means what? 2 electrons. That means 6 pi electrons. Therefore, it satisfies the Hooke's magic number 2, 6, 10, 14, 18 successively. So only cyclopentadiene anion is what? Is the aromatic compound here. Do you find this video valuable? Do you learn something? Please share this video. Follow Tutor Stanley and comment on the comment section. See you in the next video.